Hi teams, welcome back to our Ri3D build. I have Connor with me here to talk about our drivetrain and electrical systems. Connor, let's see it.
Hello. So starting off with the drivetrain, we're just using the kit of parts chassis. The reason for that is it was available and it was cheap.
Wonderful.
So it's very effective. It's got pretty much all you would need in a basic drivetrain.
What's it run by?
It's ran by 4 sim motors. Each side has 2. They're combined by a gearbox. I'm not completely certain what the gear ratio is, but that's how they're powered.
You'd be able to find that ratio easily online at anymark.com, I believe.
Yes. And then each motor is driven by a Victor SPX. So they're a very reliable type of speed controller. One advantage is they use the CAN system, which is very fast, efficient, easy to hook up. A disadvantage is if we were to use any of the CTRE encoders, those typically plug into a port on the speed controller, and the Victor SPX does not support that. A speed controller that would support that would be the Talon SRX.
Okay, wonderful. Then let's look at this electronics board a little bit more closely and see exactly what we have going on. Not quite under the hood, but we don't really have much
It's all
of a hood
out there.
here. Yeah, it's very in the open.
Yeah, and it's very nice having it out there because if something were to go wrong, and we did have an issue with the CAN chain earlier, it's very easy to see and diagnose this. As a CSA, something that I see quite often is teams put their electronics board deep inside the robot, and then it's very difficult to work with. So if you have the, if you're able to accommodate an open electronics board in your design, that's something we would recommend. A disadvantage to this is it would be very easy for someone's robot to go a little haywire and take out all of this. So a fix that we could make would be a clear panel that we could somehow temporarily fasten over this with hook and loop tape, just to protect it.
Great. We could also mitigate that with some better cord management. Better cable management would help.
Certainly.
And that is going to happen. We still have some time before our 72 hours are up. We're actually filming this early because we are ahead of schedule. Very exciting. I also noticed that we have a very accessible battery. That's always a good idea to remember. Teams, make sure that you do have a place for your battery, somewhere safe and accessible so that you can actually change those out quickly between matches. Always need a spot for the battery. Very, very important.
And our battery, we haven't added this yet, but it needs something to secure it because right now it's free over the top where we can just grab it. So an easy accommodation for that would just be a Velcro strap that goes around the top.
Hook and loop tape.
Hook and loop tape, thank you.
Legally distinct. It's important. Is there anything else that we missed about electronics here before we go into what we would have changed if we had more time? Anything we missed, Connor?
Anything we missed? I'd say that it's pretty solid for all of our needs.
Perfect. Now, what do you think we would have done if we had more than our 3 days?
First thing to note would be more sensors. So the only sensor that we have on this machine is just a USB camera that we have up here, and we're still working on using the April tags with it. With that, this may be mentioned in another video. It would be incredibly useful to have an encoder on these drive shafts. The reason for that is we have no way of controlling the arm outside of just giving it a predefined
Power level. Yeah.
So our process for that was we brought the arm up to 90 degrees parallel with the ground and just tried out different values to see what makes it hold. The reason why that's bad is through the competition, your battery level is going to go down and down and down, and eventually that predefined power level will not work.
I see.
And it also will not work for any varying angles in between.
And how would that sensor help us with that exactly? What would we have to do to make that work?
What you can do with that is you can do just a simple PID loop. So what that does is you give it a target angle to be at, and you use the encoder as your current angle, and then you do some simple PID math, which is explained in another video. I believe it's on one of our Twitch streams, to
One of the VODs,
find a power level that you could use at that moment in time to correct it.
Perfect, perfect. What else do you think we could change about the drivetrain then?
On the drivetrain,
Yeah, how could we improve this?
so something that the kit of parts drivetrain may struggle with in this competition is it's not very maneuverable.
Yeah.
There's a lot of friction when we're trying to turn. A way to solve that would be to replace these front wheels, or these back wheels and these front wheels with Omni wheels. Omni wheels are mostly shaped like regular wheels, but they have rollers that spin perpendicular to the way this wheel moves.
Okay, perpendicular to the direction of motion then.
Yes.
So you have less friction in that side-to-side, allowing you to turn more easily.
Exactly.
But the downside of that being that you can also get pushed around a little bit more easily.
Yes, certainly. And then there's other highly maneuverable drive bases, our omnidirectional drives, like H-drive, Mecanum drive. Both of those are known for getting pushed around.
And Swerve, of course, highly popular, but very technically difficult to pull off.
Difficult. It also uses a total of 8 motors, and yeah, but if you have the resources for that, it may be useful in your design.
I see.
Another change that we could make is, I mentioned we're using 4 sim motors to control our drivetrain. We could use something more powerful, such as Neos, which is a brushless motor, I believe. They're very strong, very fast.
And a little bit more expensive than Sims, so something that we deemed outside of our budget this year.
Yes, and the Sims definitely get the job done.
Absolutely.
There's really no complaints with them.
Great. Well, any last minute thoughts, advice to teams, anything that you can think of just off the top of your head that we may have missed over our electronics and drivetrain?
Definitely read the rule book very closely. There's all sorts of specifications
Always read the
on
rule book.
What gauge of wire that you have to use if you're using speed controllers plugged into the 40 amp fuses versus the smaller 20 and 30 amps. Just all of those sorts of little details. The inspectors will find it, and they'll have you replace it at the day of the competition.
And you don't want to be replacing things the day of the competition.
I've been there. It's not fun.
We've all been there. Great. Well, thank you so much, Connor.
Yeah, thank you, John.